So chapter determinants, exercise 4.6, solve system of linear equations using matrix method. Question number 7th one, 5x plus 2y is equals to 4, 7x plus 3y is equals to 5. You have to solve this system of linear equations using matrix method. So let us see how to solve this system of linear equations. Solution. So first we write the system of linear equation in the matrix form. That is, we are writing it in the form Ax is equals to B, where A is equals to A is the coefficient matrix. If you write the coefficients of x and y, that is 5, 2, 7, 3, and x is the matrix containing the variables. Here we have used the variables x and y. So x is equals to x, y, and B is the matrix containing the constants in the RHS of the equation. That is, matrix containing elements 4 and 5. Now let us check whether the coefficient matrix A is singular or non-singular. To check coefficient of matrix A is singular or not singular, let us consider determinant of A. That is, determinant of, here A is 5, 2, 7, 3. So determinant of 5, 2, 7, 3. So that is equals to, if you expand the determinant, so what we will get 5 into 3 minus 2 into 7. So that is equals to 5 into 3 becomes 15 minus 2 into 7 becomes 14. 15 minus 14, that is 1, which is not equals to 0. So determinant of A is not equals to 0. So A is non-singular matrix. So A is the non-singular matrix. Since A is non-singular, A inverse exists. So let us compute the value of A inverse. We know that A inverse is equals to 1 by determinant of A into adjoint of A. So already we obtained the value of determinant of A. Now let us compute the value of adjoint of A. So to compute adjoint of A, we need to find the cofactors. So consider the matrix A. Here matrix A is 5, 2, 7, 3. So first element in the first row, so that is A11 is equals to 5. So corresponding minor, we are denoting it by M11 is equals to. So for the matrix of order 2, so minor of this element 5 becomes diagonally opposite element. So diagonally opposite element is 3. So M11 value becomes 3. And cofactor A11 is equals to, cofactor means, if you see the suffix here, so sum of the suffix 1 plus 1 is 2, that is even number. Whenever the sum of the suffix is even, cofactor is same as minor. So value of cofactor is also 3. So next element A12. So that is the second element in first row, that is 2. Minor is denoted by M12. So as I told, minor will be diagonally opposite element, that is 7. And cofactor A12. So what will get? Sum of the suffix 1 plus 2 is 3, that is odd. When the sum of the suffix is odd, cofactor will be negative of the minor. So here what will get? Negative of minor means, so minor is 7, negative of 7 becomes minus 7. Next element A21, that is first element in the second row, 7. Its minor denoted by M21 is diagonally opposite element. So diagonally opposite element for 7 is 2. And cofactor is denoted by A21. So that is equals to, again sum of the suffix is odd. So cofactor becomes negative of the minor. So minus 2. Next A22, that is second element in the second row, that is 3. Its minor M22 is diagonally opposite element is 5. Corresponding cofactor is denoted by A22. So that is equals to, here sum of the suffix 2 plus 2, 4, that is even. So minor and cofactor will be same. So A22 value becomes 5. So we got the cofactors A11, A12, A21, A22. So adjoint of A is equals to transpose of the cofactor matrix, that is A11, A12, A21, A22 transpose. So substitute the values. A11 means 3, A12 is minus 7, A21 minus 2, A22 5. Its transpose. So that is equals to, transpose means we have to interchange rows and columns. So we are interchanging rows and columns. So write first row as first column. So first column becomes 3 minus 7. Second row becomes second column. So second column is minus 2, 5. So this is the value of adjoint of A. So if you substitute the value of determinant of A as well as adjoint of A, so A inverse is equals to, what will you get? 1 by 1, and adjoint of A is matrix 3 minus 2 minus 7 5. So we obtained the value of A inverse. Hence X is equals to, the solution x is equals to A inverse into B. So x is the matrix, that is x, y is equals to the value of A inverse, that is 1 by 1 means 1. So 1 multiplied with this matrix is again same matrix. So we can write 3 minus 2 minus 7 into 5 into matrix B. The value of matrix B is column matrix 4, 5. 4, 5. So that is equals to. So now multiply these two matrices. So if you multiply the corresponding elements of first row with first column, so we obtain 3 into 4 plus minus 2 into 5. Again second row with first column, that is minus 7 into 4 plus 5 into 5. So that is equals to 3 4s are 12. Here minus 2 into 5 becomes 10. 12 minus 10 becomes 2. Here minus 28 plus 25, that is minus 3. So this is the value of x, y. So now if you equate the corresponding elements, we get x is equals to 2 and y is equals to minus 3. So this is the required solution. X is equals to 2 and y is equals to minus 3. If you want, you can verify the answer by substituting in any one of the equations. Thank you. Have a nice day.